This is a pre-lab for the force table lab. There's a page of instructions here, but it still sometimes is helpful to see what's going on. So our spring scales, our clamps, our table, and essentially what we're doing is doing vectors again. We're going to represent vectors with arrows. The magnitude of the vector will be given by the scale, the spring scale. That will represent a force. And we'll do that in newtons this time. We were measuring in grams before, but we'll do it in newtons. And then the direction will be indicated, you know, based on what orientation it's going in. The ribbon around the D-ring on the back, and we're going to clamp our first one to the edge of the board. So it doesn't really matter what edge of the board and what position initially. Just kind of fold the ribbon over onto itself and pinch that onto the edge of the board, like so. So we've got around 3 newtons, 2 newtons, and 2 newtons here. I want a little bit variation there, so I'm going to go ahead and grab this one and pull with a little bit more force. Kind of increase these. You can change the angle on this third one and swing these around. So feel free to kind of mix these up in different ways as you do your different trials. And then just kind of, you know, tap it, overcome any friction. But we're going to put the paper with the center point right here. Now you might want to plan ahead a little bit. This is a force of 3.5 newtons. This has a force of 4 newtons. This has a force of about 4.5 newtons. So these are the stronger 2 forces. So I'm going to kind of favor this part of the paper, and you want to kind of look straight down and put a dot right in the middle of that circle. And then move your paper if you need to slightly. And then once you feel like you've got that in the middle, put a little tab, fold a little tab on the tape so it's going to be easy to remove in a moment. And then just lightly tape this paper down so it doesn't shift on you. We don't want it to move while we're doing the rest of this. And then out here on the edge of the spring scale, each one of these you need to mark where the center of the spring scale is. So that's kind of the center of this D-ring right here. So I'm going to mark out here. And you can write with pencil lightly on the dry erase board. I'm going to mark the center line here. And I'm going to mark the center line over here. And I'm marking the center line based on the center by this alignment here. The hook through the center of the number scale all the way out to the end. That's where I'm drawing my center line. And then before we remove anything, we got to write down some key numbers. So over in this direction, I'm going to do a light pencil line underneath the hook, and then we'll draw a better pencil line later on. Try not to shift that paper. We're going to write down what the measurements are in newtons, and be as precise as you can there using the number scale. So this one right here is at 3.6. It's in between the 6 and the 7, so I'll call that 3.6. So I'm going to write 3.6. It's okay if newtons. It's okay if it's upside down on your paper right now. Let's remove the spring scales, and we got to get some. We got to grab our ruler, and with these pencil marks, before we remove the tape, it's important that we draw the line out to that pencil mark. So, and you can go off the edge of the paper here with this. So there's one from the center dot to this line. There's one. Make this real light because you might erase parts of these a little bit later on. And then way out to this center mark, and the dot is the third one. And then you can kind of remove this paper. You've got the proper directions and you've got the proper magnitudes to make these vectors. We will scale these with properly scaled arrows a little bit later on. But it's ready to be removed for the second trial or for one of your lab partners to try to put their paper down and collect some data. Let's collect another set of data here. 2 of these are still clamped down, so all I have to do is drag this back over and change the angle. So let's clamp this back where, way over here maybe. Pull that around the edge. Pinch that on. And on the back, we're going to use the crosshairs in the middle. And one thing I suggest you do on the back, I'm going to change the angles here a little bit. I'll leave this one, I'll leave that one. This time I'll move this one. So good strong force. Alright, so this looks good. Let's put the crosshairs right in the middle. And one thing I suggest you do with the part 3 on the back is get the crosshairs in the center, of course, but also get one of these crosshairs, either the X or the Y axis. Line that up. Like I'm looking at this one right now. I'm going to line this up with the spring scale itself. Okay, so look down. I'm looking down like this. Look down and get that alignment as as best you can, so it's nice and straight on that line. Get your crosshairs right in the center. And go ahead and draw that pencil mark just to be sure. This pencil mark's still good. I didn't really move it. This pencil mark's still good. I didn't really move it. That's the old one. Let me tape this down while I make some measurements. Okay, so we remove one of the clamps to get these out of the way. We can swing these out. We don't have to necessarily take them all the way off. And make the marks to this pencil mark right here from the center point. That's our center point. So I use the ruler to get that line real light. I'm going to draw this real light out to the edge of the paper. So now I've got my 3 directions, I've got my 3 magnitudes, and now I can scale them. Now we have to do some of the analysis. So we have